air travel, so common and so safe today that it has become part of our everyday life. 40,000 aircraft operating 30 million flights transporting over 2 billion passengers every year. An aircraft takes off every second and we think nothing of it, yet our skies are becoming crowded with aircraft. With the world's busiest airports, such as London's Heathrow, handling over 1,000 flights a day. There is little room for error in this complex operational environment and such confined spaces around a runway. The risk of collision is ever present, and when disaster strikes, the result can be catastrophic. Dr. David Zammit-Mannion of the University of Malta and Cranfield University.
The problem of runway incursion is of serious concern to the aviation industry. On average, one runway incursion occurs in the US every day, and one every 2 days in the UK alone. Fortunately, only a small percentage of these are serious events, but nevertheless, this constitutes a major threat to aviation safety.
The National Transportation Safety Board identifies the solution of the problem of runway incursions as one of the top 10 most wanted items, and there is no satisfactory solution yet. The University of Malta, the small island state university providing tertiary education for over 400 years. The Department of Electronic Systems Engineering, led by Zammit-Mannion, is taking part in Flysafe, a €50 million European programme led by Thales, developing the NGISS, or Next Generation Integrated Surveillance System, to mitigate the risks posed by weather, terrain and traffic to aviation. Mark Fabergé from the Thales Avionics and coordinator of the Flysafe programme.
Flysafe is a FP6 European program that focuses on prevention of incidents and accidents for air transport. In this context, we have found that traffic incidents are a major cause of concern, and we have initiated new developments to prevent these.
The Department of Electronic Systems Engineering at the University of Malta was tasked with the challenge of developing a solution to runway incursions as part of the NGISS.
Our solution was to provide a system that tells the pilot what to do to avert a collision in a runway incursion scenario. In such circumstances, every second counts, so the message must be clear and easy for the pilot to follow.
Researchers Brian Zammit and Andrew Samet have been tasked with the development of the runway collision avoidance function within the traffic functionality of the NGISS. The RCAF has been designed to perform 3 functions. The surveillance function monitors traffic movements within and in the vicinity of the airport. This is done using ADS-B, through which all aircraft transmit their identification, position and speed. The aircraft performing the takeoff or landing, referred to as the own ship, receives this information and monitors each traffic movement by creating a virtual radar map. The conflict detection function determines for each traffic movement monitored whether a conflict exists with the own ship. In the event of a conflict, the conflict resolution function identifies a path the aircraft can take to avoid the collision.
The problem is multifaceted. There are technical challenges as well as human factor considerations to take into account. We must make sure that the system operates well under all circumstances, even when ADS-B received from other aircraft is lost. We cannot afford the system advising pilots wrongly during takeoff or landing.
When a collision is detected, the RCAF gives an oral warning to the crew telling them the best evasive action to take in that situation.
Go around traffic. Go around traffic.
Go around traffic.
Go around flaps.
Go around traffic.
Positive climb.
Contact clear. Stop traffic.
Stop.
Stop traffic. 300. 200.
The RCAF has been designed to be used without a display to reduce the workload for the crew. However, a specially designed map was developed to provide a means of comparison.
The nature of the alerting concept is very critical, and we have been very careful to ensure that it integrates seamlessly with the current flight deck alerting philosophies. Through training, pilots are conditioned in the way they think and respond, and this consideration is very important for such applications.
Cranfield University in Bedfordshire, England is a postgraduate university specialising in aviation research. With its own airport, strong links with industry and flight simulation facilities, the university was ideally placed to evaluate the RCAF. A rigorous evaluation was required, and this involved using line pilots flying the simulator as they would normally do in their operational environment. With high-quality visuals and simulated air traffic controllers, Cranfield's 747 flight simulator created an immersive environment that allowed the pilots to become absorbed in the scenarios. This was critical to providing the level of realism required for such work. Susan Sars, Human Factors and Safety Consultant at Cranfield University.
One of the main aims of the trials was to evaluate the RCAF from an ergonomic perspective. And in order to do this, we obtained both qualitative and quantitative data. The qualitative data was particularly important as it allowed us to obtain the views of the potential users of the system and to ensure that the RCAF is congruent with existing tasks on the flight deck.
Jason Gorchie was the research engineer at Cranfield University responsible for simulator test setup and scenario design.
The scenarios designed for the evaluations were traffic conflict scenarios, covering a range of runway maneuvers including takeoff, landing, line-up and backtrack. These varied from mundane situations to very critical ones where collision is imminent. This allowed us to confidently assess pilot reaction to the alerts in a wide variety of situations.
Once the simulations were complete, SARS then analysed the data. It was established with sufficient evidence to indicate that the RCAF resolution advisories would be acceptable on the flight deck, providing the crew with added confidence in performing a takeoff or landing manoeuvre. This was particularly the case in low visibility conditions, which is where a system such as the RCAF is most valuable. The team concluded that the way forward is to provide an alert based on an optimum avoidance manoeuvre and to direct the crew to execute the manoeuvre. The results of the evaluation have shown this is desirable on the flight deck, and this approach is believed to have significant impact on improved safety in aviation. On June 24th, an open day was held to disseminate some of the initial findings to industry experts.
What I've seen from the RCAF, it's a very good tool to aid the crew in avoiding a traffic collision. It's an excellent safety tool that gives the crew ample warning in terms of a stop, and then a distance call out towards the aircraft, which helped both my colleague and I avoid the traffic that was coming in.
I think the RCAF enhances safety in single runway operations and especially in low visibility operations, providing the pilot with distance call out to the threat. Overall, enhancing flight safety.
The RCAF is a long way from being introduced onto the flight deck, and further testing with potential users is vital to ensure that the new strategy for resolving runway conflicts is congruent with existing task requirements in the cockpit. However, it is envisaged that one day the RCAF will help to make our increasingly busy skies safer.